Artificial Intelligence Computer Vision. Overview. Learning objectives. By the end of this unit, you will be able to understand the role and importance of computer vision in AI systems. Identify key CV tasks and concepts, such as object detection, image classification, and semantic segmentation. Explain how computers interpret images using pixels, RGB channels, and resolution. Recognize the use of computer vision in various real-life applications. Use simple tools or activities to explore CV processes and visualize image data. Introduction to computer vision. Computer vision is a field of artificial intelligence that enables computers to see, analyze, and understand images and videos like humans do. It involves training machines to detect objects, recognize patterns, and make decisions based on visual inputs. For example, when you use Google Lens to scan a plant and get its name, you are using computer vision in action. Even before artificial intelligence became common, computers were already used to process images. Now, with artificial intelligence and machine learning, these image processing techniques have become much smarter. The main goal of computer vision is to recognize, classify, and understand objects or patterns in visual data. For example, identifying a person's face, reading a number plate, or detecting a road sign. Applications of computer vision. Computer vision is widely used in many fields. Let's explore how it's used in real life, across different fields, especially when combined with machine learning. Facial recognition. Facial recognition is a popular use of computer vision. It helps unlock phones, laptops, and even smart doors by recognizing a person's face. In law enforcement, it's used to find missing people or identify suspects. At airports, it helps match a passenger's face with their ID or passport. In smart homes, cameras can tell if the person at the door is a family member or a stranger. Document verification. In banks, airports, and government offices, computer vision helps scan and verify documents like passports, ID cards, or property papers. For example, when applying for a passport online, the system uses computer vision to check if the photo and signature match the records. This speeds up processes, reduces fraud, and improves accuracy. Medical diagnosis. In hospitals, computer vision helps doctors detect diseases early. For example, it can analyze X-rays, MRI scans, or blood images to find signs of tumors, fractures, or infections. During surgery, it can even monitor blood loss in real time. This saves lives by making diagnosis faster and more accurate. Retail and shopping. Imagine a smart cart in a supermarket that adds items to your bill as you place them in it. No waiting in line for billing. Computer vision helps in identifying items, managing stock, and even tracking which products sell fast or slow. It also learns customer habits, so next time, the store can suggest new arrivals based on what you usually buy. E-commerce and online shopping. Websites like Amazon use image-based search powered by computer vision. You can upload a photo of a product, and the system shows similar items available online. This makes shopping easier, especially when you don't know the name of the item. It also helps in organizing warehouse inventory and improving customer experience. Digital marketing and augmented reality. Companies use computer vision to create fun and interactive ads, like filters on Instagram or virtual try-on for glasses and clothes. In education, augmented reality turns textbooks into 3D experiences, helping students understand concepts better. Computer vision powers all these visual experiences. Self-driving vehicles. Driverless cars like Google's Waymo use computer vision to recognize traffic signs, people, other vehicles, and road conditions. It helps them avoid accidents, follow routes, and even find parking spots. This technology is also used in drones, delivery robots, and smart wheelchairs. Smart cities and homes. In smart cities, computer vision is used in traffic control, waste management, and public safety. Smart security cameras can detect accidents or unusual activity. In homes, it can help turn off lights when no one is around or unlock doors with face recognition, making daily life easier and safer. Text and sign recognition. Computer vision systems can scan printed or handwritten text and convert it into digital form. Apps like Google Translate use this to translate signs or documents in real time. Self-driving cars also use this to read road signs and symbols, ensuring they follow the rules. Google Street View. Google used computer vision to create Street View by stitching together images taken by cars and boats. Now, we can virtually walk through streets around the world using Google Maps, a great example of computer vision in action. Concepts in computer vision. Image processing. Basic techniques to enhance or transform images. Examples: adjusting brightness, removing noise, or resizing images. Object detection. Identifying and locating objects in images or videos. Example: detecting cars and pedestrians in a self-driving car's camera feed. Image classification. Categorizing an image into a predefined class or label. Example: identifying whether an image contains a cat, dog, or bird. Semantic segmentation. Dividing an image into parts and labeling each pixel based on the object it belongs to. Example: separating the road, cars, trees, and sky in a street photo. Face recognition. Identifying or verifying a person by analyzing their facial features. Example: unlocking a smartphone with Face ID. Pose estimation. Detecting the position and orientation of a person or object in an image. Example: tracking a player's movements in sports for performance analysis. How computer vision works. Data collection. Collect images or videos related to the problem. Pre-processing. Clean and prepare images. Feature extraction. Identify important parts of the image. Model training. Use machine learning models to learn patterns. Prediction. The trained model makes decisions on new images. Computer vision tasks. Computer vision is a field in artificial intelligence that allows computers to interpret and understand the visual world. By processing images and videos, computers can perform various tasks such as recognizing objects, identifying locations in an image, and even detecting specific movements or actions. These tasks are used in everyday technologies we often see around us. Image classification. Image classification means identifying what object is in an image. It looks at the entire image and assigns a label based on trained categories. Example: Google Photos automatically tags pictures like dog, mountain, or food. When you search cake in your gallery, it shows all cake images, even without you tagging them manually. Activity: Open Google Lens or a similar app and take pictures of 3 objects. See if the app correctly identifies the object. Note any misclassification and discuss why it might have happened. Classification and localization. This task identifies the object and tells where it is in the image. It draws a boundary around it. Example: In airports, security cameras automatically spot faces or unattended luggage. The system not only detects that it's a bag, but also shows where the bag is placed in the frame. Activity: Use a simple image annotation tool. Upload an image with 2 or 3 objects. Draw bounding boxes around each object and label them. Object detection. Object detection identifies multiple objects and their positions in an image or video frame. Example: In smart traffic systems, CCTV cameras detect and count all vehicles at a signal. The system recognizes cars, bikes, buses, and even jaywalking pedestrians in real time. Activity: Watch a short YouTube clip of traffic surveillance. List the different types of objects you can identify. Discuss how a computer could do the same task. What challenges would it face? Instance segmentation. This task detects objects and also distinguishes between different instances of the same type. It can recognize and label each one individually, even if they look similar. Example: Amazon's warehouse robots use instance segmentation to pick up and sort packages. If there are 10 brown boxes, the robot must identify each separately to send them to the correct destination. Activity: Imagine you are designing a system for a canteen that needs to count how many types of fruits are on a tray. Draw a picture of a tray with 2 apples, 1 banana, and 2 oranges. Label and separate each fruit with different colors. Discuss how would a computer understand this image and tell apart similar-looking apples. Basics of images. What does a computer see in an image? When you look at a photo, you might notice colors, shapes, or emotions. But for a computer, that same photo is nothing more than a grid of numbers. It doesn't care if you smiled in the photo, or if the background is pretty, it only sees pixels, each with a specific color value stored as a number. Example: Think about when you upload a selfie to Instagram. The app can apply filters, detect your face, or blur the background. Behind all this, the computer is only reading thousands of pixel values, processing them using formulas and models, not feelings or aesthetics. What is a pixel? A pixel is the smallest unit of an image. If you zoom in really close to any image, you'll see tiny squares. These are pixels. Every image is a collection of these pixels, arranged in rows and columns. Each pixel in a color image is made up of 3 components: red, green, and blue. The combination and intensity levels of these 3 colors create the full range of colors we see in digital images. Example: your smartphone camera takes photos using sensors that capture RGB values for each pixel. So, a blue sky in your beach photo might have high values of blue, low red, and medium green in most pixels. Understanding digital colors. Computers use the RGB color model, where each color is represented using 1 byte. The value of each color component ranges from 0 to 255. Example: when you watch an animated movie or play a video game, the colors of characters, background, and lighting are created by combining RGB values for every pixel on your screen, updated rapidly to create motion. Activity. Go to the given link and do the activity. What is image resolution? Image resolution refers to the number of pixels used to represent an image. The more pixels, the sharper and clearer the image appears. It is usually written as width into height in pixels. For example, 1920 into 1080 means the image is made up of 1920 pixels across the width and 1080 pixels across the height. Each pixel is about 0.26 mm, and higher resolutions mean more detail is captured. Example: when you watch a YouTube video in 480 pixels, it looks blurrier than in 1080 pixels Full HD. Why? Because 1080 pixels contains over 2 million pixels, while 480 pixels has fewer than 400,000 pixels. Higher pixel count means higher image clarity. Color images, RGB channels. We learned earlier that colored images are made from combinations of red, green, and blue values. But how does a computer store numbers? Imagine 3 transparent layers. One for red, one for green, one for blue. Each layer stores the brightness for its color. These are called color channels, and together they form a 3D array of data. Example: when you edit a photo on your phone and adjust the saturation or tint, you are actually manipulating the intensity values of these color channels behind the scenes. Grayscale images. Unlike colored images, a grayscale image only needs 1 value per pixel to show shades from black to white. 0 is equal to black. 255 is equal to white. Values in between are different shades of gray. There are no separate RGB channels in grayscale images, just a 2D array of pixel values. Example: when you take an X-ray scan at the hospital, the image is shown in grayscale. That's because only differences in intensity are needed to identify bones or tissues. Also, security cameras often use grayscale to save storage space while still capturing essential motion and details.